Okay, for the last 2 days we've been doing simple solving of equations, and they were called one-step equations because we only had to do one property to get the variable by itself. Today we're going to combine the multiplicative identity property with the additive identity property, and so we're going to do multi-step problems today. So we're going to solve equations with multi-steps. Alright, up on the board I have an equation, and it reads 4x plus 6 equals 22. Remember, the whole goal is to get the variable by itself. So right now when I look at the equation, I look to see what side my variable is on, and it is on the left. So I cover up the right side. Since I can't get rid of the coefficient, I have to get rid of whatever is with the variable on the same side. So right now there are two things that I could possibly do. I either have to get rid of the 4 or I have to get rid of the 6. Let me tell you why you do in the order that you do. If I get rid of the 4, that means I have to multiply through by the multiplicative identity for all 3 terms. That can get a little messy. It's not wrong, but it definitely isn't the easiest road to travel. So my first thing I will tell you is use your additive identity property first. Okay? So once we've established that, what do I need to get rid of? I got to get rid of the 6. And the additive identity property says that I add the opposite. And the opposite of 6 is negative 6. And remember, after I use the additive identity property, I am really using the reflexive property as well, because negative 6 is equal to negative 6. So I bring down my variable, those two go bye-bye, and I have 22 minus 6, which is 16. Now I've created another equation, and since I've already used the additive identity property, now I'm going to use the, what property? The multiplicative, let's try that again, multiplicative identity property. So what do I have to get rid of? Cover up the other side of the equation, and I have to get rid of the coefficient. And to get rid of the coefficient, I multiply by the multiplicative identity. So what is the multiplicative identity of 4? It is 1/4. So I multiply through by 1/4. Now remember, there's different ways of showing that. I could have had either way is fine, but you need to remember this is the multiplicative identity property. All right, so when I multiply through, that gives me x, and 16 times 1/4 is 4. And over here, if I chose this way, it would have been x is equal to 16 divided by 4, which is 4. Am I finished? Absolutely not. What do I need to do? I need to check. So I go back into the original problem, 4, leave out the variable, plus 6, and is that equal to 22? Well, we found the x to be equal to 4. So 4 times 4 is 16 plus 6. 16 plus 6 is 22. Is 22 equal to 22? Boom, boom, check, check. And therefore my solution is x is equal to 4. Let's do another example. let's do example number 2. I have 2/3 is equal to 1/5 x minus 3. Okay, I have a coefficient with my variable, and when I cover up the other side of the equal sign, I also have a 3 that I have to get rid of. So what am I going to do first? Well, like we stated in the last example, I'm going to use the additive inverse property first. So what is that? That would be adding 3 to both sides. Now when I add 3 to this side, they cancel out because that gives me 0, and I have 1/5 x. Now here's where the fun begins. When I take 2/3 and add it to 3, that gives me 3 2/3. Oh no, oh no. But we can't leave it that way. What do we have to do? We have to write that as an improper fraction. So 3 times 3 is 9, 9 plus 2 is 11, over 3 is equal to 1/5 x. All right, so that's my identity of addition and my reflexive. And now let's check what else I need to do. I have 11/3 is equal to 1/5 x. Cover up the side that doesn't have my variable. And now what do I have? I have 1/5 x. And I have to have the coefficient of my x to be 1. So now I need to use the multiplicative inverse property, which means I'm going to multiply by the reciprocal. So the reciprocal is going to be 5. So that gives me x on the right, and then 5 times 11/3 is 55/3. Do I need to do anything else with this 55/3? No, it's in lowest terms, and it's an improper fraction, and we're cool to go. But am I finished with the entire problem? Absolutely not. What do I have to do? Check. So therefore, I go into the original equation. 2/3 is equal to, and I have 1/5, leave out the variable, minus 3. Plug in 55/3. That gives me 2/3 is equal to, 5 goes into 5 once, 5 goes into 55 11, so that would be 11/3 minus 3. So what is 3? 3 would be 9/3. So 2/3 is equal to 11/3 minus 9/3. So 2/3 is equal to 2/3. Boom, boom. Check, check. So my answer is 55/3. Let's do one more, and I'm going to make it a little crazy, as if this one wasn't. All right, example number 3. Example number 3 says 2 plus 5x minus 10 is equal to 40. What's the first thing I need to do? Well, the first thing I need to do is locate my variable and look at that side. All right, this is what I have. But now my little siren goes off, because before I ever start messing with the variable, I really need to look at my sides and see, can I combine like terms first? If you forget to go and combine like terms, you're going to forget some stuff along the way. So before I ever start with my additive inverse or my multiplicative inverse, I better look and see, hey, can I clean this baby up? And absolutely I can, because I have like terms. I have a 2 and a negative 10. What is 2 and negative 10? That gives me negative 8 plus 5x is equal to 40. All right, now I'm ready to do the solving. Please, please, please do not forget to combine like terms. All right, so I locate my variable, and I have to use the additive inverse property first, so that means I have to get rid of my negative 8. What do I do to get rid of the negative 8? I add 8. So I'm going to add 8 to both sides. Why don't I add it underneath here? Because the reflexive property says 8 is equal to 8. It doesn't say 8 and 8 is equal to 8. It just says 8 is equal to 8. So now I'm ready to combine. These cancel each other out to be 0. Bring down this, and it is positive 5x is equal to 40 plus 8, which is 48. Why do you think I made a big deal out of bringing down the positive? Well, I want you to get in the habit of bringing it down, because if that's a negative, you can't leave it up there. All right, so now I'm ready to use the multiplicative inverse, which is multiplying by the reciprocal, which is multiplying by 1/5. Or in this case, I could write it as dividing by 5. Those cancel out. X is equal to 48/5. Do I need to do anything to that? Nope. Let's go check it. So I have 2 plus 5 times 48/5 minus 10, is that equal to 40? So I have 2. My 5's cancel each other out. That would be 48 minus 10. So that would be 50 minus 10. That would be 40. So, is 40 equal to 40? Absolutely it is. So therefore my solution is x is equal to 48/5. Let's do one more example, example 4. Okay, example 4. 3x plus 10 minus 5x is equal to 8. The first thing I want to do is I want to look and see, can I combine like terms? Yes, I can. So I have 3x and a negative 5x. When I combine those, I get a negative 2x. So I have 10 minus 2x is equal to 8. Now I don't have any like terms on the left. I don't have any like terms on the right. So now I'm ready to solve my multi-step equation. I'm going to use the additive inverse first. And I have add 10, so that means I'm going to subtract 10 from both sides. Those cancel out. Leaves me negative 2x is equal to, and 8 minus 10 is negative 2. Now I'm ready to use the multiplicative inverse, because I use the reflexive property by saying negative 10 is equal to negative 10. When I get here, I'm going to multiply by the, multiplicative inverse. And the multiplicative inverse of negative 2, is it 1/2? No. Because a negative times a negative will give me 1. So my multiplicative inverse is really negative 1/2. And I multiply that on both sides. So now I have negative 1/2 times negative 2, which gives me x. And then I have negative 2 times negative 1/2, which gives me 1. Now I need to go back up into the original equation and solve my check. So I'm going to go up here and I'm going to go 3, leave out the x, plus 10, minus 5, leave out the x, and see if that is equal to 8. So where my x was, I'm going to replace it with 1. So 3 times 1 is 3. Negative 5 times 1 is negative 5. And let's simplify that left side. 3 plus 10 is 13. 13 minus 5 is 8. So is 8 equal to 8? Yes, it is. So therefore, boom, boom, check, check. My solution is x is equal to 1. All right, guys, I'll see you tomorrow in class. Have a great evening.